Hey guys, today I'm going to be talking about data collection methods for critical power. So first of all, this concept doesn't really apply to sports where the athlete has single or few muscle contractions like archery, shooting, throwing, things like that. It doesn't really apply to athletes where they have a lot of rest time during the event, so American football, baseball, things like that. And then finally, it doesn't really apply to sports where power output doesn't exceed the critical power, i.e. golf and then ultra endurance events, both of which you probably won't be hitting a maximal lactate steady state or even close to VO2 max. That being said, if you want to use this as a conditioning tool for these athletes, go right ahead, it'll work perfectly fine. So, just to review what this video is, it is just an instructional presentation on the various methods of collecting data for critical power. It's not a review on critical power's physiology or relevance to training. It's not a review of the mathematical models. It's simply just a review of different methods of data collection for critical power. So, keep in mind throughout this entire video is that there is no standardization yet for calculating critical power. It really is up to what you choose. There are lots of different guidelines of how long the test needs to be, how many tests you need to do, things like that, but there is no set protocol like the Bruce protocol for measuring VO2 max or things like that. So keep in mind, use what method works best for your situation. Some of these methods include the 3-minute all-out testing method, the constant work rate test, the time trial test, and then some of the other ones that aren't as popular and I would say kind of go into these or can be kind of added as means of collecting data within these three main ones is historical data, GPS data, or test-retest validation. I'm sure there are other means of collecting data for critical power. However, for this video, I'm mainly just going to go over these three bolded ones here. So, some considerations, at least in my opinion, before you decide to select a data collection method are, one, what mode of exercise do your athletes compete in? So, if you have cyclists, you should probably use a cycling test. If they're runners, use a running test. Swimmers, swimming tests, so on and so forth. If you want to prescribe, wattage for a bike for HIIT training or something, you need to get critical power data. If you want to prescribe a speed or pace that someone needs to work at, then you probably need to get critical speed data, so on and so forth. The second consideration is the setting and tools you have available. You can have a state-of-the-art laboratory with, COSMED, metabolic carts, and means of collecting blood lactate levels and things like that. Or you can simply have a dirt field and a stopwatch. It doesn't really matter where you collect data. It is possible to collect data in any kind of situation. You just need to make sure you pick the data collection method that matches your setting and the tools you have available. The third thing is you need to make sure you understand how many tests you have allocated to testing. Some of these protocols require multiple testing days or hours of testing. If you don't have that, then obviously that's probably not the test for you. The fourth consideration is the number of athletes you're testing. If you're using a test where you have to test the athletes multiple times or you have to pay particularly close attention to each athlete, and you've got a soccer team of 30 guys, then it's probably not best for you to use that kind of method because it's going to take you all week or more to get some dependable results. The fifth and final consideration, in my opinion, is really looking at the validity of what critical power is testing for. And to me, if you don't have really highly motivated athletes, chances are you're not going to get very good values for critical power. the reason why I say that is because unlike VO2 max or lactate, where those are physiologically based parameters where I can look at it and say, yes, like his VO2 max didn't hit steady state, or it did hit steady state. I can tell that how hard he was actually working. Critical power is a performance-based calculation, which means however the athlete performs, that's the number you get. That number doesn't necessarily tell you whether you're good or bad or ugly or whatever. It just simply says, okay, this is the number, and then how you prescribe training will be based off that number. So if you get an athlete that sandbags the test, then you're going to get a sandbag critical power value that won't be very good at prescribing effective or optimal training, conditioning training for that athlete. So jumping right into the first data collection method, which is the constant work rate test. To sum up what this looks like, pretend you had a cyclist and you said, I want you to cycle at 300 watts until you fail. So you set the bike to 300 watts and they cycle and cycle and cycle, and let's say they say I can't go anymore, and that took 5 minutes. That would be considered trial number 1. And based off that, you pick another wattage. So let's say, okay, now I want to test them for 200 watts and then see how long it takes them to fatigue at 200 watts. The same can be done for running in the case of a treadmill, or swimming in the case of a jet that allows your athletes to swim at a certain speed, which I can't say is super readily available, but I'm sure it's out there. So the next method is really the time trial method, and this is probably one of the more popular ones as compared to the critical, or not critical, but the constant work rate test. As you can see, it's been validated in more modalities of exercise than the constant work rate, and it also only requires space and a timer. So how this goes is you can either pick a time you want the athlete to work or a distance you want the athlete to work. All you need to do is record how far they go or how long it took them to fatigue. So for example, if I had a swimmer, I'd say, hey, I want you to swim as fast as you can for 800 meters, and then I'm going to record how long it takes you to swim 800 meters. And then we're going to do another trial and another trial, and that's how we're going to calculate critical power. The flip side of that is if I said, I want you to exercise for 3 minutes as hard as you can, or 7 minutes as hard as you can, and then I just measure how far you actually got during the test. Bottom line of both of these tests, even though they are very similar, is that there is no standardization, which means there's a lot of speculation to the optimal test duration, the effort, the number of tests you use, and the rest between each test. Also, both of these methods require you to use a mathematical model to calculate critical power. That being said, all those choices you make will determine the critical power value ultimately. If you want a simple guide on how to calculate this mathematically, use this link right here, and that just takes you to a video of me talking about how to take time trial or constant work rate data and then calculate critical power and corresponding variables. So the last main method of data collection is the 3-minute all-out test. Now, this one is probably, I would consider the gold standard, even though a lot of people consider the constant work rate the gold standard because it was really the first. However, the 3-minute all-out is really leading the way as far as future critical power measurement and application in sport and prescription and training. And really, it's because it's the simplest, the shortest duration, and it can be done almost anywhere. So really what this looks like is if I have a cyclist, I just say, okay, I just need a means of measuring their wattage. And so I say, I want you to go all out as hard as you possibly can for 3 minutes straight. So they start off going as fast as they can, they build up to their top speed, and of course you can't hold that maximal sprint speed for more than a few seconds, so then inevitably they're going to drop down until you take the wattage that they worked at for the final 30 seconds, or the average of that wattage, and that is your critical power. Just note, if you want to read any papers on this, that critical power, the terminology is a little different. However, in critical speed, the terminology is the same. If you still don't quite understand what I'm talking about or what this might look like, use this link, and that'll take you to a video not affiliated with myself that shows a guy doing a 3-minute all-out test on a bike, and is, I think, a very good representation of what the test is. So since I like the 3-minute all-out test so much, I figured I would give you a practical application of this with a sport that I like a lot, which is rugby. So first, you can see that I've put these cones out on the rugby field. I've got me here with my stopwatch, and after we would do the warm-up with the entire team, I'd tell the athletes, make sure you gradually build up to your top speed in about 5 seconds to avoid any hamstring strains or anything like that. And then I would also tell them that I'm not going to tell them how much time is remaining. This plays into how much motivation, how motivated these athletes are to go all out during this test. The other thing I would do is I'd ask them to round these turns as much as possible. Now, even though this has been, 3-minute all-out has been validated for shuttle testing, there is an amount of error with starting and stopping. So for this example, I would just have them try to round the turn so it made it as a continuous running test as possible. And quite simply, if they had GPS units, I would have the forwards go, and they would start and then do their 3 minutes. And then I'd have the backs go, and they would start and do their 3 minutes. And by the end of the test, I would have the max speed they reached in the first few seconds of the test. I would get the distance that they went within the 150 seconds of the test, and then get the average speed. And then finally, I would get the average speed they went at for the last 30 seconds, which would be my critical speed. And at the end, I would take all those numbers, and then I would calculate the d prime using this equation right here. So quite simply, you've got a test that, including warm-up and instruction and everything like that, as long as you have GPS like Catapult or StatSport, you have a test that has now mapped an athlete's fitness qualities from max speed to recovery run speed. And you did it in under 30 minutes, so that's pretty powerful. So a practical takeaway from this entire video is really that all these methods have their pros and cons. It really is dependent on what is best for your situation. In some cases, with professional cyclists or coaches that I've talked with that train professional cyclists, they've said we have no days to train, so they can't even do the 3-minute all-out. They simply take the power meter data of peak 3-minute power, peak 10-minute power, things like that, to then calculate critical power. So in that case, the 3-minute all-out wouldn't be the best. Runners, also, if you don't want them to sacrifice a training day or recovery day, then you can take what their personal bests were for a mile or a 5K or things like that if they're really fast, or if they're actually, collegiate level or higher, and then use those values to calculate critical power. So right here, I've kind of laid out examples of what I would do in certain situations because it is so variable. If you have GPS, I've already talked about that in rugby that can be applied to soccer. If you don't, there are methods of using video or just doing time splits manually with a stopwatch as well. If you have an individual athlete, again, you can use their race data, their best efforts in training, and or any kind of power meter data. In closing, the key points of this entire whichever method you want to choose is that specificity and consistency are king. Make sure you test in the same environment and administer the same tests every time. You also want to make sure you get the most information out of with sacrificing the least amount of training time, and you also want to do what can be used in your situation. These are my references. Thank you so much for watching, and be on the lookout for more content coming soon.